Hi all, it's the 9th of August 2023, and a large wildfire has burned through the town of Lahaina on Maui in strong downslope winds north of annular major Hurricane Dora. But there was a much larger force at play, and let's take a look at it in this video. On the evening of 8th of August 2023, a large wildfire swept down to the lowlands of West Maui and burned through Lahaina, damaging and destroying many buildings, sending people running for the water to escape the flames. We're still learning what happened on the ground, and we do not know whether people were hurt or killed in this tragic event. The fire heat signatures were captured both and seen from both GOES 18 and out on the very edge of the limb of the Himawari 8 view. Media reports are blaming Hurricane Dora for the strong winds that fanned the flames of the fire. This is certainly part of the story, even though the hurricane was far south of the islands. The reason for this is the impact of having an intense low pressure moving around the edge of a large and strong high pressure system. Low pressure on the edge of high pressure means a greater difference in pressure over a shorter distance, known as the pressure gradient. This is the driver of the winds. But there are a couple of other things to consider here. The first is this large high pressure north of Hawaii. Big deal. Hawaii usually has a large high pressure to the north. It is, after all, the driver of the trade winds that gives Hawaii its climate. But let's take a closer look at this high pressure by going back in time. Several days ago, the high pressure was really a complex of highs further east near the west coast of North America. Over the next several days, the high pressure shifted westward and strengthened. Meanwhile, Hurricane Dora was pushed westward along the southern flank of the high pressure. On the 5th of August, probably due to the dry air near the high pressure and low wind shear over the storm, Hurricane Dora became an annular hurricane. An annular hurricane is one that has limited or no rain bands, but an intense eye wall, a donut-shaped storm. This type of hurricane is known for being particularly resilient against unfavorable surrounding environments. But the high pressure was doing something else. It was bringing a slab of dry air that had collected off North America across the East Pacific to the north of Dora. We can see the movement of this dry air here by looking at the humidity roughly at the heights of the mountains of Hawaii. As Dora moved well south of the Big Island early on 8th of August, the dry air to the north reached the islands while the wind strengthened due to the increased pressure difference between the high to the north and the major annular hurricane to the south. This explains the large-scale setup that brought dry air at mountain heights and stronger winds. But this disaster, like most weather-related disasters in Hawaii, is linked to the mountains themselves. From media reports, it seems that the winds became exceptionally strong on the lee side of the West Maui Mountains, which, by the way, actually have the wettest spot in Hawaii, excluding Kauai at the summit of Pu'ukukui. But Lahaina itself lies in the lee of the West Maui Mountains, and this causes a couple of problems with regard to fires. First of all, Lahaina lies in the rain shadow of the mountains, so it is dry. But secondly, and critically, being on the lee makes it possible that downslope wind events can occur, as seems to be the case here. Put simply, when you look at a rock only just submerged in a river, you may notice that the water flows down faster on the downstream side. The reason for this is the stable lid, the water surface, being close but above the top of the rock. The same applies here, but instead of a water surface, the lid is the so-called trade wind inversion, a very stable layer within the trade wind atmosphere that lies above the trade wind shallow clouds that Hawaii so often experiences. Some kind of critical conditions have to be met where the downslope winds can develop into a so-called hydraulic jump, where the winds accelerate down the lee of the mountains, becoming much stronger than the general large-scale flow. In this case, we may be able to recreate the event using high-resolution weather models case studies in the future. This is something that we have the capability of doing here at UStorm using the WRF model, but we'll need time and maybe money to do it. In the meantime, thanks for watching and wishing the best to Maui in the tackling of the fires ongoing and for the recovery.